Recording this session, and as you can tell, you were looking at my desktop. Let me open up my digital whiteboard. This is what I will draw on. In other words, if we're looking at ratios, you can see all of that?
Yeah.
Okay. So, I have your book, right? I don't have the same edition, but I've got your book, I believe.
Yeah.
Do you have problems out of the book you want to talk about, or are these special ones your teacher gave you, or?
Hold on. My math binder's stuck in my backpack. There we go. Cut it out. So I was given. We weren't really given a homework assignment tonight, so.
Can you verbalize some of the problems? Can you just read them to me, and I'll write them down, and we can solve them?
Well, we weren't given a homework assignment tonight, so.
Oh, you weren't? Okay, I thought you said you were.
No.
Okay.
No.
So what are we going to work on tonight?
Well, I mean, obviously, this is all to get me prepared for the ACT, so is there any stuff you know that I could start learning now?
Definitely. I got tons of ACT tests there.
Sweet. I'm going to ditch my math notebook and get a different one out. Sweet.
This is not going to be primarily geometry. It's primarily going to be a mixture of algebra and geometry, but that's all right.
Okay. Yeah.
I mean, the only way we can work on specifically geometry is if you bring some geometry problems.
Yeah, we need homework.
That's fine. I know that happens. But this is good. I mean, you need to work on ACT stuff also. So,
yeah.
Can you solve that?
So, I see it. I see half of it.
Can you solve that equation right there?
Yes.
Go ahead. What's the next line?
5x plus 3. So, 3 minus 3.
Work out loud. The way this works best is if you tell me what to write for the next line.
Okay. So I want to get the I want to get that -3 and that 17 together.
Okay. So I'm going to subtract 3 from both sides.
Correct.
That leaves 5x over there. What happens when I subtract 3 from -17?
-20.
Okay. Now what?
Now I want to get that 5 away from the x, so I have to multiply, right?
Divide. Always do the opposite of what's being done. Notice that the 3 was being added, so we wanted to subtract it. The 5, the x is being multiplied by 5, so we want to divide it. That'll get rid of it.
But I thought you couldn't divide a negative.
No, you can.
Okay.
You can. In other words, the 5's cancel, and I've isolated the x. And now on the right side, it's -4. So the answer would be C.
Okay.
Okay? Let me move this a little bit here so that I make room for my writing tablet. Okay. You can see the whole question?
Yep.
Okay. I'll go ahead and let you read it to yourself. Merely because when you do take the test, you won't be reading it out loud. So we want to practice in the mode that you're going to be in. In fact, you should have a calculator with you also. You have a calculator in front of you?
Yes.
Go ahead and get it, because you are allowed to use it on the ACT. So some of these you'll want to use the calculator. Although in all honesty, the calculator really doesn't help very much. They structure these questions so that they're not really calculator questions. I mean, there might be some minor mathematics to do, multiplication, division, addition, and subtraction, that you could use the calculator on, but in general they'll be single-digit numbers, so it's not like you need to use the calculator on them.
Okay.
Now, one thing about the ACT test is that they will frequently give you problems that have completely irrelevant information in them. So just because they tell you that there's 4 oranges, 5 pears, 10 apples, and 2 dozen strawberries doesn't mean that all of those numbers are important.
Oh, yeah, because he wants to serve, he says, what? His fruit salad serves 6 people, and he needs to serve 18. All we're doing is figuring out how many pears that takes to.
So how many are? What's the answer?
Fruit salad recipe, 6 people. 5 pears for 6. 12 would be 10, so then 12. Hold on. Yeah, so it'd be, he needs 15 pears.
15 pears. Notice that it didn't matter how many oranges, apples, or strawberries there were.
Yeah.
Completely irrelevant. Now, this is actually a ratio problem. Okay? In other words, 6 people is to 18 people.
As 5 oranges.
As 5 is to x. And we're solving for x. Cross multiply, you get 6x equals 90, x equals 15.
Okay.
Okay? So that's a straight ratio problem.
Okay.
Now, these problems tend to get there's going to be 60 in each test, and the first 30 tend to be a little easier and medium, and your harder questions come towards the end. So don't be too surprised that these might be a little easier than you're expecting.
Okay, yeah, because I took the pre-ACT.
Uh-huh. Yeah. So what's the greatest integer that is a factor of both of those numbers? In other words, what is the greatest common factor? GCF, greatest common factor. If I wrote just this, those 2 numbers, what would the greatest common factor be?
2?
Uh-huh. In other words, I could factor out a 2, and I'm left with 4 and 3. There's no bigger number than 2 that divides evenly into both 8 and 6. So that's what we're looking for, is we're looking for a number that divides evenly into these 2 numbers, the biggest one that's on their list. So 2, we've already isolated the fact that 2 is going to be the biggest number. It's not 1, it's not 6. So the answer is either going to be B or D.
Okay.
What power of 10 will also...
D.
Did you say D?
Yeah, it has to be because 2 times 10 to the power of the 6 was too much because 6, it's more than 6 to the...
Exactly. In other words, if I go to divide this, it doesn't divide evenly. But if I divide 10 to the power of 3, it divides evenly into that, and it also divides evenly into that. Okay?
Okay.
Let me open up another page here. I've got like 8 of these practice tests. Each one of them has 60 questions in it. So I've got gobs of material. If I can just figure out how to size it so that we can see it. Hold on. My mouse usually is what... It's funny how when I'm using my cursor, I don't have enough dexterity to do it properly. Try writing with a mouse sometime. If I try writing a mouse and I try writing letters, it comes out like I'm spastic.
I see that.
Yeah, but if I write it with my cursor, I can make nice looking letters. It's weird.
Oh, also, I apologize if my dogs bark. My mother's not here, so.
Oh, that's okay. I got no problems. If I get through the whole session without apologizing to you for my dog barking, I'll be surprised because my dog usually barks sometimes too.
Yeah, I got 3, so mine's quite a bit.
Oh yeah, yours are probably a little noisier. So what's the area of this rectangle?
3 by 4. The area would be 3 times 4. That's. Oh, sorry. Hold on. Yeah, that's 12, right?
Okay.
That's the area.
That's the area. 12's the answer. All right, let's go on. It looks, I'm going to make a statement here that may be a little premature, but it looks like you could use some practicing on multiplying and dividing single digits by single digits.
Yeah, I don't have my multiple tables as down as I should.
Okay. I run into a lot of students that are in that shape, and I don't blame any of you because you grew up in the calculator age. And when you have a calculator and you have a choice of doing stuff in your head or doing it in the calculator, most people choose the calculator because they know they're going to get the right answer. Whereas if you do it in your head, you might get the wrong answer 1 out of 10 times. So people end up relying on the calculator because of its accuracy, and then people completely lose the ability to do multiplication and division in their head. The problem is that any kind of higher math at all, whether you're talking algebra or geometry, you don't want to have to rely on that calculator to multiply 3 times 4. It's just too slow. Or to add and subtract numbers. When we were in the earlier problem, when we had minus 17 minus 3, you want to know how to be able to do that by hand. And if you don't know, we need to focus on that. Now, the only thing I can suggest to take the ACT, you will improve if you knew your multiplication and division tables by heart perfectly. It would improve your ACT score by 10% minimum.
So what number would that be though? Like,
doesn't matter. Doesn't matter. Yeah. What I'm saying is that that's how important it is to be able to do single-digit multiplication and division in your head. Is regardless of the fact that you're going to be allowed to use a calculator, it still is going to cost you 10% in your score. Just because. And I think you'll see why as we go through these problems. Okay. It's not just a question of speed even. Obviously, it's easier to multiply 3 times 4 in your head than have to type it out on a calculator. So there's more reasons than just speed why it's necessary. And there's not, I understand that at this point it's not real easy for you to go back and perfect that skill.
Yeah.
But there are lots of assistance. If you have a smartphone, you can get a free app that will let you practice your single-digit numbers by single-digit numbers, multiplying and dividing. You can go on a computer, just go into Google and say digital flashcards. I don't know if you ever used flashcards when you were a kid, but when I was a kid, that's how we mastered our multiplication and division tables, is we had little cards on them. And the correct answer was on the back of the card. And we just drill.
Yeah.
It was like I spent 3 hours a day in elementary school drilling multiplication and division tables. And I'm not kidding you, 3 hours every day. That's what we'd do, is we'd go up to the board and the teacher would shout out problems, and the first one that got it stayed at the board, and the other person sat down. So we got lots and lots of practice, and that is what you need, some of. It's not going to require my help because I can't really help with it. It just requires you to memorize. You need to do your 2s, your 3s, your 4s, your 5s, and all the way up to your 9s. Any single-digit numbers you want to be able to multiply in your head. And whatever you need to do to master that. I'd be happy to work with you on it in our sessions, but I don't think that's the most efficient use of our time.
No.
But it is something that you need to address. You will do a lot better on this test if you get a little bit better with your arithmetic. All right, look at number 5.
5?
Uh-huh. So let's see if I can draw this hat. I'm a pretty lousy artist. Okay, it's not too bad. So he wants to put a white silk band around the very top. Okay?
Okay.
The radius from center to there is 4.
So the whole way across.
The whole way around it is the circumference of that circle. What's the formula for circumference?
I know it's like radius times pi, something like that.
Okay, area is pi r squared.
Wow.
Circumference is the same 3 digits, only it's 2 pi r. Those are 2 formulas you definitely need to memorize. The area of a circle and the circumference of a circle. Notice that if you give me the radius, I can give you both the area and the circumference. If you give me area, I can give you the radius. Or if you give me circumference, I can give you the radius. In other words, radius is everything for a circle. Radius tells you everything you need to know about a circle. There is nothing else important except radius. But only if you know these 2 equations. One way to memorize area that I like is area is pi r squared. Well, pi aren't squared, they're circular, right?
Yeah.
So that helps. A memory technique is often an absurd variation of what you're trying to remember. I know that pi aren't square, they're circular, but that helps me remember the expression pi r squared. And then memorizing circumference is just take the 2 and stick it in front. So this question is asking about circumference, right? Not area. We don't care what the area is. That would be the area of the top of the hat. We just need how far it is around the circle. So we want circumference. So in this case, what's circumference going to be?
C2 times 3.14 times...
Now leave it in pi. Look at the answers. They're all in pi.
Oh, okay.
In general, we don't convert pi to 3.14. Pi is a better expression than 3.14 is. 3.14 is an approximation that's been rounded off, whereas pi is an exact number. So we're just going to fill in 4 for r, we get 8 pi. And that's the answer.
Okay.
Okay? And you should always look at the answers before trying to solve the problem. A lot of times, a lot of good information will be exposed by the answers that you're looking at. For example, if we would have converted pi, if we would have gone to all the trouble to convert pi here, we'd have then had 6.28 times the number 4. When we do all that work, we get 25.02, and that number is not one of the answers. So now we got to do a whole bunch of work to convert 25.02 back into pi. So by looking at the answers first and knowing that our answer is going to have pi in it, keeps us from making a bad mistake early on in solving the problem. In general, you're not going to want to convert any pi's to 3.14. They pretty much give all the answers in terms of pi. Okay, we got a large jar that holds 48 olives, a small one that holds 32 olives. What is the expression needed to fill X large jars and Y small jars? Little difficult to figure out which one.
Well, I know what it's not.
Okay. Let me suggest another way to solve this. Pick some numbers. When you're doing the ACT test, the goal is not to show anybody how much mathematics you know. The goal is to get the questions right. So there's generally 3 methods for any question. One of them is the algebraic way. That's usually the hardest. The other one is back solving, where we look at each answer and see if it's correct. We go back and try to solve and see if it's correct. That doesn't work very well on this problem, but picking numbers works great. By picking numbers, first of all, let me tell you that what's the key for why we should pick numbers. It's because the question has 2 variables in it, an X and a Y, and all of the answers have those same 2 variables. So it doesn't matter what I pick for X and Y. In other words, it's going to be true for any X and any Y. So let's just pick X equal 2 and Y equal 3. In other words, if I had 2 large jars and 3 small jars, how many olives is it going to take to fill those?
Oh, so it's F, because
exactly.
You're multiplying by how many jars there are. I got you.
Exactly.
Okay.
And
So
by picking numbers, the first thing you're going to do is you're going to say, well, it's 2 times 48, and then it's going to be 3 times 32. Well, that looks an awful lot like what this expression does. So by picking numbers, really to finish out the picking numbers philosophy, let me just finish what I would have said. So there's going to be 98 olives for the 2 large jars. There's going to be 96 olives for the 3 small jars. So that totals 192 olives. So we know that if we had 2 large and 3 small, we'd need 192 olives. Well, if I couldn't have made that connection that you did make, the other option I now have is to go into each of these answers, plug in 2 for X and 3 for Y, and see which one comes out to be 192. Notice that G wouldn't, H wouldn't, J wouldn't, and K wouldn't. I don't think K would. But the one that definitely does come out to be 192 is F. 2 times 48 is 96. 3 times 32 is 96. Add those 2 together, you get 192. And we know that's what the answer has to be as long as X is 2 and Y is 3. So picking numbers, you don't even need to be able to make the connection that you made. In In other words, you made it immediately. The moment I picked x is 2 and y is 3, you knew it was f. Because you were doing the mental math. You were doing x times 48. Ah, that's f. Okay. This, you pretty much have to know what they mean here. Let's take a simple one. Here, let me cover this up for the moment. What is f of 3? If f of x is x plus 1, what is f of 3?
I do not know.
Plug in 3 for x. That's all it means.
Oh.
Okay?
That'd be 4.
So that would be 4. What is f of x squared?
That's, well, there's nothing else on the right side, so.
The answer is whatever is in the parentheses, plug in for x.
Yeah.
So it's x squared plus 1. That's what this notation means. Is that if I give you a function, then if I give you a function with a number or another variable inside the parentheses, take whatever's inside the parentheses and plug it in for x. That's what this notation means. So, here, a little more complicated, because f of x is equal to 3x squared plus 4. And they're asking, what is f of x plus 1? Also notice their answers. All have x in them.
We all have 3 squared.
Okay, so what's the first thing I'm going to do? Let's take it step by step.
Well, I could plug in x for x, but that's...
No, you got to plug in x plus 1. Everything in the parentheses. So wherever I encounter x, I'm going to plug in x plus 1.
So, yeah.
Like that. It's as simple as that.
That's the answer?
Well, almost. It is the correct answer. It just hasn't been simplified. In other words, this is the same as one of these answers, but we're not going to figure out which one it is until we distribute and multiply this out. So what is x plus 1 squared equal to?
2x plus...
Hold on. Foil it.
Yeah, 2x plus...
Do you know FOIL?
Yeah, oh no, so x plus 1.
Well, x plus 1 times x plus 1. First of all, let's do the first. That's x squared.
Yeah.
And then we do the outside. That's plus x. And then we do the inside. That's the I of FOIL. Another plus x. And then we do the L, the last, 1 times 1. So x plus 1 quantity squared is x squared plus 2x plus 1. So let's write that in place of this. In other words, the 3 isn't being squared, but the x plus 1, the entire thing is being squared. So I'm now going to write, in place of x plus 1 squared, x squared plus 2x plus 1. Now I'm almost done. I still need to distribute it. Distribute that. What do you get?
So that'd be...
Multiply 3 by each term in the parentheses.
So 3x squared, and then that'd go plus 6x plus 3.
And this plus 4 still there.
No, Yeah, plus 4.
And
And then you can
now,
add the plus 3 and 4 together.
so we end up with, that's the answer that should be on there. And it is E.
E.
In other words, they will always simplify. It's very unlikely they're ever going to put an answer on there that is either this or before I raised it, whatever it was. In other words, they're always going to simplify.
Could you hold on one second? I have to let my dog out. She's staying by the
Sure,
door.
sure. I'll switch pages while you're doing that.
Hi. Hi. Come on, go.
You back? Yeah, cool.
Hold on, she's still out there.
Okay.
Good girl. Good girl. Hey, come on inside.
Ah, there was my dog. My dog heard your dog.
Yeah. All right, I'm back.
Okay. Let's talk about problem number 8. Might look like this would be very easy to solve in your calculator, right?
Yeah.
You want to give it a shot?
Yeah, hold on, my computer just freaked out for a second here.
Okay. In fact, let's not make it hard on you. Let's have you add 5/6 plus
There we go.
5/8 plus 1/3 on your calculator.
Well, I'd have to get common. Wait, no, I'm adding, so I don't need common denominators, right?
Well, that's right. Go ahead and try it.
I don't even need a calculator for this because it's 11 over...
No, you're going to need a calculator. I want you to try it on the calculator just to show you what the problems are going to be if you tried this on a calculator.
Okay.
So try adding 5/6 plus 5/8 plus 1/3 on a calculator.
Actually, my graphing calculator is out of battery, so I've been doing this part from my iPhone.
Ah, okay. What it's going to give you is a decimal answer. Notice that we don't have any decimal answers. So, in other words, if you were to try to do this on your graphing calculator, you're going to have a problem. It's going to give you an answer, but it's going to be a decimal, and we don't know which of these answers is going to represent that decimal. So, this is a perfect illustration of a problem we don't want to do on a calculator. The slow way is going to be on the calculator. However, there is worth noting something here. If we're adding these three numbers, I can separate out the whole numbers from the fractions. I can add the whole numbers together. I can add the fractions together, and then after I'm done, add the two things together to get the answer. So separating out the fractions is a good start. We know what 5 plus 3 plus 1 is. We're carrying forth a 9 plus the sum of these three fractions, right? How do we add these three fractions?
Well, it's addition, so you can just add straight across, right?
No, we need a common denominator.
Oh, we do? Is
Uh-huh.
that multiplication? We can just do
If
that?
multiplication, you can multiply straight across. Multiplication and division is far easier than adding and subtraction. Adding and
Okay.
subtracting is actually quite a bit tougher because you have to find common denominators, you have to pay more attention to the signs, plus and minuses can screw you up more. Multiplying and dividing is a piece of cake compared to adding and subtracting. So let's go through the process of finding a least common denominator. How do I find the least common denominator?
We need a number that goes into all of them, but
Actually, we need a number that all three of these goes into.
oh yeah.
So the way you do it is you start with the biggest one, 8. Is 8 divisible by all three of those?
Divisible? Like,
Is it evenly divisible?
no.
Okay, so that's not our common denominator. Now, go up one multiple of 8. Is that evenly divisible by 6 or 3? We know it's divisible by 8 because I went up by a multiple of 8.
Yeah.
So it's not. 6 doesn't go into 16.
No.
So let's go up by one more multiple of 8. Is that divisible by 6 and 3?
Yes.
So that's our least common denominator, and that's how you find it. So now let's rewrite 5/6 only with a denominator of 24. What is 5/6 equal to if it has a denominator of 24? What's its numerator?
551.
Divide 6 into 24 and multiply it by the numerator. 6 goes into 24 4 times. 4 times 5 is 20.
Oh, yeah.
Okay? You can see why this single-digit multiplication and division is so vital. It just becomes an inherent process that you do internally. And if you have to externalize that to a calculator, you're never going to be fast at it. And you need to be relatively fast at these single-digit problems. So let's do 5/8. How many 24ths is 5/8?
So isn't it? So it's 8 times 24.
8 goes into 24 how many times?
3 times, right?
Okay, and then 3 times the numerator.
That's 15.
Okay, how about 1/3? How many 24ths is 1/3?
3, 6, 7. Yeah, 8. So that's 8.
8 times 1 is 8. So here's our 3 fractions with a common denominator. Now we can just add the numerators, bring over the common denominator. What's the numerator here?
It would be 20, 15, 8. That's 28 plus. All right, hold on. Just give me a second.
Okay.
I'm trying to do this mentally. That's 43.
Okay, good. So I still have the original 9, right? Nothing happened to that. So the answer is 9 and 43 24ths. Well, the problem is that when I look on there, that answer isn't going to be on there.
Yeah.
Why?
Because 43 can go into 24.
Okay, so what's my correct answer? In other words, 43 24ths is greater than 1. So if I want to pull a 1 out of that,
yeah.
How many do I have left over?
24 goes into there once.
With how many remaining?
Like
19.
19.
Uh-huh. So now I could write it 9 plus 1 plus 19/24, right?
No, 10, 19, 24.
Exactly. Now, can you kind of see why a calculator would have made this difficult?
Yeah.
Because the calculator isn't going to do the least common denominator for you. So the calculator is probably going to give you an answer like this.
Yeah, and that's
And
not
then
helpful.
you would have the problem as to which of these numbers is equal to that. So this is actually a classic example of where a calculator doesn't help and it almost hurts if you try to rely on it. In other words, it's useful to know. Yeah, let's pass that one for a moment. Number 9. Let's look at 10. Excuse me. Tell me what your thought process is in trying to solve this problem also.
Well, I see that he has to learn 2 pieces in a week. And if she gives him 3 new pieces every week for 4 weeks, it would take, well, after, so 2 to a ratio of 2 to every 7 days. I mean, every 7 days. And then if she gives him 3 for 4 weeks, that's 3 times 4 essentially. So that's 12 pieces total, right?
Uh-huh.
So then I need to find a.
If I give you 12 pieces to learn and you can learn 2 every week, how many weeks is it going to take you?
2. So 2 for 1 week. So we see how many. So 2 every week. So
Take 12, take the total she's given you, and divide by 2. And that's your answer.
that is. I just thought that was too simple.
No? It's as straightforward as that. What makes this problem complicated and potentially problematic for people is if you try to do it the following way. If you tried to say, well, in week 1, I'm going to do 2 of the 3 she gave me, so I will have done 2, but I'll have 1 more to do, plus 1. And then in week 2, she's going to give me another 3 pieces, so I'll have 4 to do, and I can do 2. So there's week 1. You see how much harder this is going to be if I try to do it this way?
Yeah.
In other words, if I try to work chronologically through each week, how many I've done, it becomes a nightmare to solve. But if you do it the most straightforward way, which is to look at the second sentence first and realize that she's giving you 12 pieces to learn, if I give you 12 songs to learn on your guitar and you can learn 2 a week, that's pretty straightforward. 2 songs per week, that equals 6 weeks. So as long as you do it that way, the problem is very easy and straightforward. It's only hard as if you try to do it a different way. All right. We don't have much time left, but maybe time for one more, and it's a geometry problem. How appropriate. Number 11. And if you can see my little hand here, what it's telling you is that this angle here is 35 degrees. And this angle here is 65 degrees. So if I draw a picture of it, I get 35 there, 65 there. They want to know what x is.
Well, isn't it all triangles have to be 180?
Okay.
So you do 65 plus 35. That's 100 even, so it's just 80.
80 is the answer. And that's the geometry that you have to know for the ACT is nowhere near as much as what they teach you in your geometry class.
Oh, so what you're saying is what I'm going to learn for the next semester isn't quite going to be as ACT practical?
No, it's more than practical. Well, yes, that's what I am saying. They're going to teach you a lot of stuff in geometry that you don't have to know for the ACT. There's a few basic core things with geometry that you have to know. One of them is that the sum of the angles of a triangle add to 180. Another is if I have a straight line, what is the sum of A and B equal to?
180.
If I have two crossing lines,
That would be 360.
which angles are equal to each other?
AB are equal to each other, and AC, that's an A, right? Yeah, AC.
A is equal to C?
Well, what's that one below B? And A and C?
D.
Oh, it's D. Okay, yeah. AB
B is equal to D. In other words, whenever you have two lines that cross, this angle is equal to this angle, and this angle is equal to that angle.
Yeah.
Okay? Another core geometry thing that you want to know is that there's not a lot, but the stuff that you're supposed to know, you want to make sure you know it. Really, really good.
Yeah, I mean, like, mostly as far as this tutoring goes, I mean, like, every now and then I definitely want to learn the ACT stuff because I didn't do as hot as I'd like to in the math area.
Well, the ACT is going to be important to you getting into college. Probably as important as your grade point average is. That's how important it is. If you have a chance, if somebody, the devil, came to you and offered, I'll give you an extra 10% score in your ACT, but you got to give me 10% off your grade point average, that might be a good deal for you. That's how important the score on the ACT is. You know what I'm saying?
Like yeah.
Okay.
You got the best GPA ever, but score awful on your ACT, and it could hurt you.
Colleges aren't going to like it. Whereas if you had the other way around, you could have a really crappy GPA, but if you had a really good score in the ACT, colleges are going to look at that. They're going to say he may not be able to get a good grade. Maybe he didn't do his homework, but he knows the math. If you can get a good score in the ACT, it shows you know the material. So they weight that very heavily. But I agree that we probably should be working on your geometry. If you had an assignment today, that'd be a better thing for us to work on, since you're only a junior. In other words, you got a lot of time to do your ACT. You basically have 8 months. Your final ACT you'll probably take next fall. You'll probably take it once this spring, and then you'll take it again in the fall. But that's it. In other words, you could take it a year from this spring, but by then you'll already have been either accepted or denied into the colleges you're trying to get into. Right. So the last practical time to take the ACT is the fall of your senior year.
Okay.
Okay. Are we going to do this time regularly?
You have to ask my dad about that. I mean.
Okay. I'll just wait. I'll wait and let you guys make an appointment online like he did this one. And if you decide that you want the regular spot every time, let me know and I can lock it up so that nobody else grabs it.
Okay.
Okay? But this is the way it worked. It seemed like it worked pretty good. We had good audio the whole way. I have recorded this, and I have your email so I can send you the link. It probably won't be until tomorrow morning, but I can send you a link that will allow you to view this tutoring session again if you want. Or if you wanted to show your dad how it works or something, you know, you could play it. and I'll get that to you either later tonight or first thing in the morning.
Okay. Yeah,
Okay?
I'm on the email probably like 3 or 4 times a day, so it's a great way to reach me.
Okay. Sounds good. That phone number that you called me from, is that the number? In other words, the next time we have an online session, I won't need to call you. I'll just need to send you the meeting ID number. What I usually do is text it to people. So I will send a text to this phone number. This is your cell phone?
Yeah, is it 720-785-0466?
Yeah.
Yeah, that's my cell phone.
That's your cell phone. That's where I will send a text 2 minutes before whatever the next session you schedule will be.
Okay.
Okay?
All right.
Talk to you then. Have a good week.
All right, you too. Bye-bye.